So, welcome back. Let's do a quick recap of what we have discussed so far. So, we we understand that Prisma SD-WAN has a cloud controller. We have branch sites and DC hub. We have underlay transport. We have overlay VPNs. Uh, we we have a we we have a centralized control plane where all the config is stored, which is a source of truth. How to determine your region is done from Strata Cloud Manager dashboard, Prisma SD-WAN. You can locate your region. You can follow the portal for the activity happening on your on your region, and how to be updated. When the changes are getting applied, so that you know that the portal won't be available for doing any modifications. It doesn't have any impact on your data traffic. Then we saw about the various Lego blocks, the components of Prisma SD-WAN, and yeah, we navigated the Strata Cloud Manager UI. We saw the different pages which are applicable to Prisma SD-WAN. We discussed about the interface types, which is the foundational um, uh, component of Prisma SD-WAN, which is very important to understand to build a branch site. So in one topic I would like to cover with regards to interfaces, if you look at the legend over here, if you look at this image over here on the screen, you have a controller port, you have an internet port, you have a WAN to LAN port. If you see, there's a red color icon here on this port, which indicates the port is admin down. So this is very useful when you're logging into a Prisma SD-WAN branch site. Uh, you, you need a snapshot of what is happening on your interfaces, whether it's a WAN interface, LAN interface, uh, or a MPLS interface, what is going on in your network. When you get a call from a user saying things are not working in the branch, so is the port connected physically? If the port is not connected, it will be white in color. If it is connected, it will be highlighted like this. Like if it is admin down, you'd have a red color icon on the right corner indicating that port is being admin down. So probably you did a config on the CLI, and after the device was restarted, it got up the controller, as I mentioned, as a source of truth. The config gets pushed into the device, and the port goes down. So then you'll be able to correlate what's going on in your network. Then you have a tick box here, and you don't have a tick box here. So the tick box indicates the config is complete. Okay. W1 stands for WAN, L1 stands for LAN 1, W2 for WAN 2, L2 for LAN 2, and this is the Gen 1 device. So this particular legend for ports is what important. It's important to understand what it tries to tell you. So if we go into the Strata Cloud Manager, if you go inside this device, under the interfaces is where everything is shown. So over here you have the virtual ports, you have the ports, you have a controller port, you have port 1, port 2, port 3. This is the virtual form factor. These two ports are admin down. Now, for when you have this port 1 over here, and if you remove this circuit label, if you remove this circuit label and save this port, immediately if you see the tick box is gone, which indicates to you that something is missing in this config. Okay, so the moment you cancel it, you will see the tick box is back. Okay, so that's the difference between a port with a complete config and a port which has an incomplete config. When a port is connected, you will have the ports highlighted in blue color. Okay, so this is for the ION. This is very important to understand. This helps you a lot to understand what's going on in your network. And then this is an image of okay. So this is a ION 1200 device which has a cellular interface, and this is the signal for cellular, and this is how the LAN ports and WAN ports are shown. I mean, how uh, built on the new Gen 1 Gen 2 device. So you have a WAN port. Again, as I mentioned to you, it's admin down here. These are PoE ports. This is a cellular port. So this will give you a footprint of what's going on in your network. Okay. So uh, yeah. So now we go into the circuit labels. So circuit labels are uh, how we define your WAN circuits are, what exactly, uh, and we use it primarily for setting up your path policy. So when we have an internet port or an MPLS port, and we want to set it up as when we have a circuit label attached to it, what we do is we use a path policy to use the circuit type to define which traffic goes from this circuit, which traffic goes on circuit 1, and which goes on circuit 2, which goes on LT circuit. So according to this, you will define, and you also define the bandwidth capacity of the circuit. The port itself is 1 gig, but actual capacity which is available from the WAN provider would be 30 meg or 100 meg. So this config is configured inside the circuit label. So as I mentioned, there are two types of circuit, private and public. You have circuit category and circuit definition. These are an abstraction of your WAN WAN config, which is applied on the site. And whenever you replace your device and you apply it on the new device, it inherits the config and inherits the path policy through this identifier circuit label. Okay, so under the circuit information, we have bandwidth monitoring, link quality monitoring, bandwidth configuration, quality of service. Um, what exactly we do is we have circuits like LT circuit where you don't want to do the bandwidth measurement because it's already a low. Uh, it is a what do you say low capacity circuit where everything is charged, everything is built. So you can disable these monitoring features on the circuit label. So over here, that's a quick demo. If you go down to the Strata Cloud Manager, if you go to the branch site, over in this particular branch site, I have two ISP circuits. When I click on change circuit and edit this circuit, I have all these parameters. Can I configure 1 gig? Yes, I can configure 1 gig here for the download and upload. The cost for the circuit is default by 128. You can higher the cost, the least preferred it is. You can define the cost for it. The bandwidth configuration, bandwidth monitoring, uh, the LQM monitoring. If you don't want to monitor the LQM, you can disable it to no. So all this is configured from this one. Whether you want to use this interface, this circuit for controller connection, yes or no. So sometimes the connectivity to LT may not be reliable or may be constantly flapping. So in that case, you can disable connectivity to the controller through this configuration. Okay, so this is all about circuit label. So here you have the circuit category, and the path policies are defined for a WAN path to be applied on a circuit category, a circuit type, and according to the circuit type, the traffic for different apps can be forwarded. Okay. The next one is the VPN overlay, secure fabric link and service link. Okay. There are two methods you can connect your IAM device to remote endpoints. Uh, the one is secure fabric VPN, which is auto VPN created by the controller itself, and the another one is the service link. Service link or Prisma Access VPN, or the Prisma Access VPN, or the Secure Fabric or the standard VPN. Okay, the Secure Fabric VPN is available under the overlay connections. So you have the data center. Under the data center, you have the circuits assigned to this branch site and the circuits to which the VPN is built up. You have the status one by one, and you can go and see which ION device we are connecting to, and and see the status of this, which is available here. So here, if you see here, this is an active VPN between the branch ION and the data center. On the branch ION, it is using port one. Sorry, on the port one on the branch ION connected to port one of the DC ION, and this is the cipher it is using. This is a keep alive and the failure code. The standard VPN is a VPN which can be connected to third party as well as for Prisma Access. So here we have an example of a standard VPN. And standard VPN here, it's connected to India North endpoint. It shows the IP address of the endpoint and it shows the status of the VPN. Okay, I'll just show you a quick demo. Okay, so over here, if you go to overlay connections, we have branch to DC, branch to branch to standard VPN, branch to Prisma Access. So when I click branch to Prisma Access, I see this VPN is being created between the India North endpoint and the branch circuit towards ISP1. Okay, so over here we have the branch to DC VPN, which is a secure fabric VPN, and as I mentioned earlier, it is between the two ISP circuits assigned to the branch connected to the data center. So when I click on this, and here I would see the VPN link itself. It's active. It's between the port 1 on the DC ion, port 1 on the branch ion. Okay. In addition to what we see here for the Prisma Access VPN or the standard VPN, you can click on this interface and see what is this VPN configured to the endpoint, the endpoint, and then the IPsec profile, and view it from the interface itself. The unified app ID. So the Prisma SD-WAN is primarily uh, routes the traffic to your WAN parts based on application. Based on application is the core functionality of the SD-WAN. So you have a specific app such as Office 365, MS Teams. You have Google Apps. You need to forward this traffic towards your direct internet. You need to forward this traffic towards Prisma Access. You use the app engine to do the detection of the application, and then the Prisma SD-WAN branch ion forwards the traffic based on the policies which are being defined. So this particular unified app ID, it is coherent. It synchronizes with the Prisma Access also. Both of them have the same. We have the increased number of applications supported through this, and starting with 601, Prisma SD-WAN can use the unified app ID. Prior to 601, we use the legacy apps which are limited, but now we have then the app engine is unified to both Prisma SD-WAN as well as Prisma Access. Under the app ID, we have broadly types of apps. One is system app, and the one is a custom app. System apps are predefined apps, approximately 4,000 plus apps, which have been created by default and available for you to apply on your policies. The custom apps could be something which is private to you, which is something you would like to define yourself based on L3, L4, or L7 match criteria. So in the Strata Cloud Manager, under the Manage Prisma SD-WAN resources applications, you would see this portal where you have list of all the applications available. As I mentioned to you, there are two types of applications, either system app or custom app. You have the device version compatibility mentioned, saying that the ION device should be running 601 and above to 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 use this application, and if it is below 601, you can use this particular application. Okay, the category of the application and the subcategory all available. And if you want to create a custom app, you can add an application over here and define the app based on the parameters which are specific to this application. So as mentioned, SCM, Manage, Prisma SD-WAN, resources application. So this is a tenant-wide uh, attribute that is defined across the tenant. So any changes made here will be pushed to all the branch devices. All the ions are then connected to the SD-WAN, Prisma SD-WAN infrastructure. So you need to be a bit cognizant about how you want to do it and what are the impact, business impact. When you apply this config for a custom app, you're creating a custom app, how is it going to impact another branch which is sitting in a different geographical location? So a little bit of planning or guidance is required on how you want to build these applications. But this is something which need to be take a little bit of caution, because once you configure it, it will be immediately pushed down to the branch IO. The branch routing, for this session, we're discussing the Prisma SD-WAN branch routing only for static and the BGP. So as I mentioned, the routing is done for the WAN peering as well as the LAN peering. We support BGP as well as static. As Michael asked during the chat that we do support OSPF from 6.4 and above. What is required for the routing to work in a branch? You must have L3 forwarding enabled, and the site needs to be in control mode. So if you set up a BGP peering, and if you try to see that the BGP never comes up, the most likely reason could be that the device, the branch is mode, control mode is in disabled state. So you will see the BGP resets happening when the branch is set up into a disabled mode. So you need to have a control mode. You need to have L3 forwarding enabled on the LAN for the BGP to work. Okay. So how to set it up? Startup Cloud Manager, workflow, Prisma SD-WAN, devices or branch sites. Yeah, you can use either one of them. Select your branch and then go inside the ION and then configure the routing. Or you can go to workflow, Prisma SD-WAN setup, devices, routing, and configure the BGP. So BGP, we support the full BGP implementation. We support both 62-bit as well as 32-bit autonomous system. Classic peer is the only type of BGP peer we can configure on a branch side. BGP configuration used for all peers that are local to that are defined in a branch. The config is defined under the global config. But if you would like to have a specific peer with a different AS number defined for the local, you can use the peer level configuration. So you have two configs, either the element global config or you have a peer level configuration. And the menu we have the prefix advertisement under the global configuration, which can be unaggregated, auto aggregated. So if you have two prefixes /25 prefixes, it will aggregate it as /24 and advertise to reduce the number of prefixes that is exchanged with the peer. Manual summary only and none. So these are the different types of advertisements supported under the global config. For the static routing, we have a destination prefix, we have a next hop, we have a scope. So we define the prefix to which we need to route the traffic. We have a next hop up to 8 is supported. It can be either an IP next hop or it can be an interface next hop. So when you select an IP, it will forward to a specific IP. If you select an interface, it will forward all the traffic through the interface to the interface defined under the static route. So over here, if you see, the by default it is part of global VRF. It's some and you can define the specific VRF if you require. This session we are not discussing about the VRF, so we, we limit our discussion related to the destination prefix, which is the prefix to which you need to route the traffic. We have the next hop reachability probe to verify the next hop is reachable. We have the scope, whether it's a local or global. So then again, now this prefix could be a local to the branch, or it could be something which other branches need to connect. So depending on whether it's a local or a global, you can set up the scope of the static route. So if it is local, it is not published to the fabric. If it is global, it is published to the fabric. So let's say you have a transit network where you connect the ION device to the layer 3 switch in the downstream, where you have where you are peering with where you have connectivity to the LAN L3 switch, and you would forward all the prefixes which are connected behind this transit network to the downstream switch. They will be defined either as a static route or a BGP peering, learn through BGP. So when you define to a static route, you will define it under this particular yeah. So you would set it up again, devices routing static, and you would set up the next hop, you'll set up the scope, you'll set up the, if you need any next hop reachability probe, you can enable it and define your static routes. Okay. So just have a quick look at this routing. So when you go to the routing, you have BGP. This is the global config. So when you click on edit, it will apply to all the peers. This is the AS number. This is the default advertisement, auto aggregated or unaggregated. The LAN side, manually aggregated, manually summary, or unaggregated. And then you have an advanced config where you can define the timers and apply it. Okay. And then you have the individual peers where you can either inherit the global config or define config specific to this peer. So if you want to have a different timers for this particular peer, you can define it. So this is the BGP peer. You have, in addition to this, you have route maps, prefix list, AS path list, IP community list, which you can attach it to this peer, define it and attach to this peer. Static routing, as mentioned here, you have a destination prefix, you have the scope, which is global, you have the admin distance, next hop IP, um, and then whatever you set it up as static global scope, you would see that prefix available here under the advertised prefix on the site. So technically, this whatever is global would be available for other branches or other other locations in the Prisma SD-WAN infrastructure to connect and access this particular subnet. Okay, so next one. So this completes the routing part of uh, the branch, both static as well as BGP. So branch services we have mainly the DHCP, SNMP, and Syslog, which is used by most of the users. We'll cover these three. In addition to that, we have DNS, we have NTP, we have um, we have IP fix, which is net flow. So today we'll limit ourselves to these three main topics, which is pretty common deployment in all branches. So DHCP, the ION device can replace your DHCP server for the branch. So how do you? Yeah. So the it's a very common service. You don't need to have a dedicated DHCP server at your branch site. You can leverage the Prisma SD-WAN ION to function as a DHCP server. So you can, like any DHCP server, it has a scope definition, it has static mapping, it has custom DHCP option, it has lease timers, it has a domain name, it has an IP range, it has an exclusion. So we will see how the DHCP deployment can be. You can use the ION, to leverage for your as a DHCP server for the local branch. So to configure a DHCP server, you have the branch configuration. Under the branch configuration, you have the configure DHCP scope. So as I mentioned to you, this is part of the site configuration itself. So when you replace your ION, all the config is inherited from the site and then gets applied to the downstream and immediately starts working as a DHCP server. To configure DHCP server, we click on the branch, we select the branch, we go into the configuration and click on configure DHCP scopes. And once you click on it, you would see a menu like this where you can add your DHCP server, you can create your subnet, your broadcast address, your domain name, your description, your tag, and apply it on the particular branch. So over here, if you look at when you create a DHCP server, you have this subnet which is required. Then you can have a broadcast address. Uh, just to remind you, this particular thing is to make the ION itself as a DHCP server. If you want your downstream device to connect to a DHCP server which is available in another branch, or it is connected, it's behind your data center, you can use the DHCP relay under the interface, LAN interface, to forward the DHCP traffic. This is for the ION itself to function as a DHCP server instead of just forwarding the DHCP messages to the defined DHCP server. So you have a subnet, you have a broadcast address which is populated, you have a gateway, you have a DNS server. You can add up to 3 DNS servers. You have the lease time, you have the IP range which you would like to for this particular subnet to be used for the leasing. You have the static mapping as well as the custom options. DHCP lease static reservation. So you have the static menu. Under the static menu, you can click on this triangle and then define your static mapping. So you can use the MAC address as an attribute to statically assign a specific IP towards this specific MAC address when the request comes in. You have the DHCP lease, MAC address and for the binding. So if you look at this one in the static mapping, you can configure the IP and the MAC address you would require to have the static mapping for. The DHCP scope options also have custom options. So this is very common for IP telephony, where you would like to define your own custom options such as TFTP server, or you want to define um, your WLC server IP. So you can use the vendor class ID option and definition and the value. So if you need guidance on a specific custom option which you would like to configure for a specific IP telephony platform, we have a lot of knowledge articles available where you with step-by-step guidance on how to configure it. So this is all about the custom options supported in the under the DHCP server. So just a quick demo here. So here, as I mentioned, here we have the DHCP scope. Okay, so when you click on it, you can add the DHCP server. You can restart the DHCP server. You can edit the scope. So under the scope, you will see the subnet, the broadcast address, the gateway, domain name if available, the DNS servers, the range, and the static mapping, as well as the custom options. Okay. So the moment you type anything, you'll have an option to save and exit, and immediately it will start applying to the IO device. Okay, so this is DHCP. Next one is SNMP. So SNMP, we both support the SNMP agent as well as Trap V2 and V3. Both the versions are supported. We can configure the SNMP under the device SNMP tab. You have a separate one for agent, separate one, menu for agent, and separate menu for the tab. SNMP V3 agent can be configured by enabling this V3 tick box, and then you get a prompt here to add the user, where you define the security level, authentication type, your and the other parameters required to define the SNMP V3 configuration. SNMP traps are available under the traps menu, where you define the service IP, the source interface from which the traps need to be sent to the SNMP server, and community if any, and then save it. So when the moment you can even disable it. Suppose you want to configure and leave it offline until your SNMP server is available to take the trap message optionally, or if you can keep it enabled. When there's a maintenance, you can disable and keep it. The server IP and all the other parameters. So source interface is very important. The reachability between the source interface and your SNMP server is a prerequisite for this feature to work. Syslog. Syslog is for exporting the syslog from the ION device. Again, there's a source interface which needs to have reachability towards the syslog server. By default, it chooses the controller interface, or you can choose manually which interface you would like to send. The logs are exported based on the severity chosen. If you choose all levels above it, if you choose minor, then it will include major also. So it depends on the severity. At a minimum, what you select, it will be forwarded. By default, it uses UDP protocol. You can opt for TCP and define the server port number and the server IP for your syslog server. So now we have completed the branch services and interfaces and VPNs. So the core components of a branch site, which we saw, have been completed so far. The last one is the policy. So policy is a big topic by itself. So what we intend to show you this today is the default policies which is available, that helps you start running your branch site, and how to try to understand what this policy is trying to do by default. So even though it is automatically created, it is available in your tenant, it gets applied by default. How it functions, how these things interact, and later you can build complex policies, according to your requirement. And probably we can do another session in future where you can explain how to combine the various knobs available within the policy to 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 create a complex configuration or a simple configuration as per your requirement. But today's session, we are limiting ourselves to the three important policies which are required to be required to be there for any branch site, namely the path policy, the QoS policy, the NAT policy. Security policy is optional. It's not mandatory to have it. So we will limit our discussion to these three policies and the default policies available in Prisma SD-WAN. Okay, so as mentioned, policies are managed from the manage page of Strata Cloud Manager. Under the manage page, we have policies and resources. Policies, we have binding, path, performance, QoS, security, and NAT. So bindings are for mapping different policies for path, QoS, to a specific branch site. Path itself is applicable to the path policies, how you forward the traffic from the branch ion towards the to the WAN path. The QoS is for prioritizing your traffic, to do traffic shaping. Then you have the NAT. So essentially, if you take any branch side, you need to do a source NAT to forward the traffic to the internet. That is the default requirement of any branch side. So which is already being by default created. The zone is created, and the zone gets assigned to your internet ports. Uh, we'll look into this default at configuration, which is getting deployed on your branch side. The resources are for applications, which we discussed during the unified app ID. The circuit categories is where you create different categories of circuit, the network context, service and DC group, probes, security zone, site templates, and prefix filters. These are the resources are kind of a child of the policies. So if you need to define a security policy, you need to have a security zone. If you need to define a path policy, you need to understand the prefix filter. You can get the path prefix filter and then apply that inside the path policy. And then same applies for the network context. So if you have a network context defined, that network context can be applied on your path policy. So resources are like complementing your policies, and like uh, the knobs available within the policies to configure and to use them the way you want to use it, the way you want your branch to function through these policies. So another thing is the central theme of this policy is for configuration abstraction. The policy is at the tenant level. You create it once and use it n number of times. If you have 1,000 branch sites and you have 7 main types of branch types, you create a policy once. You define your policies. You understand like how these branches need to function, divide them into categories, and then configure it. Once you configure it, when you onboard a new site, you apply the config, and then it will function the way you have defined it. So it's very important to plan how you want to use these policies. And today's session, we're just going to touch uh, the, the, the tip of the iceberg, which is the default policies. But however, this can be a very powerful tool at your hands, at your disposal to configure and fully utilize the strength of the Prisma SD-WAN. As I mentioned, the Starter Cloud Manager under the Managed page, the shield icon over here is where you have the policies and resources. The resources. These are the two primary locations wherein you would build your policies for the Prisma SD-WAN branch sites. The policies are applicable only to the branch, not to the data center. Data center is just transit forwarding the traffic. So each branch site must have a policy for path, NAT, and QoS. Site, we have a policy that can apply to n number of sites. Optionally, you can have a security policy set. It's a zone-based firewall where you have interfaces mapped to zone, and then the security policy rule set defined to be applied on the particular policy for the branch. A user can create a new or a custom policy or use one of the default policies provided. Again, this default policy is not mandatory to use. It's available for you to use. It's available for you to understand how this policy works. And then you can totally ignore it and create your own policy and then apply it on a branch. Policies can be cloned and edited. So this is a very, very useful mechanism for troubleshooting. So if you have a policy and you suspect that there's something not right about this policy due to which the traffic is not going the way you intend it to go, then you can clone this and then manipulate this policy so that you don't impact all the branches which are connected to this policy. You just create a clone, apply it on a branch, and then start using to play with it so that you know that this is the policy I'm changing and this is going to impact only a branch side. Okay. The policies can be further. There's an attribute for a Prisma SD-WAN branch side called domain. So there may be the organization, the tenant can be connected to branch sites which are spread geographically across all the continents. So in this case, you can define and scope each of these branch sites into a specific region. It could be North America, EMEA, APAC, China, or within a country, you can define them into different domain, subject to how you want to use this attribute. And under each domain, you can then map them to sites. So this what it helps you is these particular branch sites within this domain will only speak to the data center which is available in North America. It won't be stretching itself to go all the way across EMEA to fetch some resource from your data center. So this is a very useful, very powerful way of controlling how the traffic flows on your WAN, on the overlay towards your data center. So this will help you to control this traffic. You don't necessarily would like to use a high latency um, traffic path while you have a faster connectivity towards your local data center. So this policy is this the particular attribute domain can be used the way you like to use it, but this is one of the examples of how you can use it. Path policy rule itself has different I say knobs available. So one of them is order. So you can list the policy set, policy rules, and then put them under order. Like you can have a default rule saying that all the traffic will go towards that delay, and on top of that you can define the specific apps like Office 365. You need to go and under this go to Ethernet internet. If you have another, you need another traffic, for example, for Google Apps, you need to go to ISP2. Office 365 goes to ISP1. So the order defines how the policy is applied to the branch. Okay. The network context, as I mentioned, is an attribute available where you can create your own context and apply policies for that particular context. So a typical use case is the guest traffic connected to the branch, where you can apply specific rules for guests. So your guest traffic, you don't want to send them towards your data center. You want them to go directly. You don't want to backhaul the traffic to the data center. You want to send them to LAN delay. So you can use the network context. Source prefix. So if traffic is coming from this particular LAN source prefix, what do I do? How do I forward them? If I get a traffic for a specific destination, how do I forward it? So these are the two attributes available within the rule for you to define. And finally, the most important one is the application. So these apps, how do I forward them? And the paths allowed. So under the paths allowed, you can filter down the paths which you want to send forward. You don't want to use a LT, you can create them as L3 failure path, active path, backup path, and L3 failure path. These are the three types of path we can forward the traffic to. And then finally, the service or DC, which applies for your DC transit traffic towards the data center. So the default policy sets for path, QoS, and NAT, we have a default rule, which by default it allows all paths for all traffic. You can modify this to limit it to a specific WAN path, and then according to that it will apply. It doesn't impact any private IP. So any traffic destined to the internet, destination internet, will fall under the default rule. Enterprise default is for private apps. Anything which is an RFC 1980 destination. The same applies for QoS and NAT. So by default we have this default rule for and the enterprise default rule created for you, and it gets applied when you select the default path policy set for a particular branch site. This is what gets applied to. For the NAT, it's a little bit different. By default, we create an internet zone. Internet zone is already available. It gets assigned or mapped to your internet interface. The moment you select this, use this port for internet, the interface gets bounded to the interface zone. So while the internet interface gets binded to the internet zone, the NAT policy has a default destination rule which says any traffic which is coming towards this interface gets source netted, SNATed, and gets forwarded to the internet, because the private IP is not routable over the internet. So the default SNAT is created for you, and it's part of your default NAT policy. And the default NAT zone is also created. And the moment you select the port as port type as internet, it gets assigned to this particular zone. Okay, we'll see how this default policy set. So as I mentioned, manage Prisma policies path. Under that, you'll see, when you click on it, you'll see path stack, path set, and path prefix. So the path stack can have the path sets, multiple path sets. And the path set has the rules. So this is the abstraction of how we configure your path policy. Under the default paths policy rule set, you have two rules, as I mentioned, default and enterprise default. So under the default, this is for non-RFC 1980 destination. By default, it includes all the WAN paths. You can manipulate the way you want it and filter out the paths you don't like to have it. And enterprise default is for the private apps. Um, for destination, which are RFC 1918, you can modify this to specific prefixes which are applicable to your infrastructure, and then this rule will apply for those traffic which are destined to be towards the which has the destination of RFC 1918, which is nothing but a private app within your network. QoS, we have again the default sets, and then the traffic destined to internet is prioritized as silver, and the traffic for the private apps is gold, prioritized as gold. The NAT policy set, we have NAT set, default set, we have a destination zone rule, which is nothing but source NAT for the inbound traffic coming towards the internet port, and then we have a NAT zone by default created for internet. Now you can use these default policies to learn how they work, and later clone them or create your own, and then create your own set, create your own rule, and then apply it and test it out. Okay, so just a quick demo for this. Okay, so when I go to the manage Prisma SD-WAN policies, you have path. Okay, so when we go here to the path, we see the path set, and we have a default set. This rule has two rules over here. Click on it, and here you go. So this is the default rule for the internet bound traffic. This is for private apps, enterprise default. So when you click on default, you would see the the attributes I mentioned earlier. So you have an info with the order number. So based on the order, the policies are applied. The lower the order, the more preferred it is. In the network context, we don't have any network context because it's empty. So in order to build your network context, you need to go to resources, go to network context. Okay, so my mouse is a little bit fast. Yeah, go to network context, and then we add a network context. So we call them suggest. You can save it. The shield icon. Remember the shield icon. So once you go to policies, go to path set, and then click on it. You have the default rule, and under the network context, okay, so this is a default rule, so you cannot modify or select any context over here. So if you want to create your own network context, so you add a set, call it test, and then under this test we can add a rule, and under the rule we can get a test. We can create the order as 100, and then go to the network context, and then we can add the network context as guest. Then prefix here, enterprise prefix or none, and then we have the, this is for users, it's a new feature we have. You can select the apps to, then the path. So over here we have, okay, so we have Prisma SD-WAN VPN on any public, we have standard VPN on any public. So these are the different paths we have. We have active path, backup path, and the L3 failure path. Okay, finally you see the summary, and then you can save and exit it. Okay, and now if you take a branch site, if you go to the workflow Prisma SD-WAN branch site, go to branch sites and select a branch, you would see the rule applied over here. So if you want to modify this stack, policy set stack, you can go to manage Prisma SD-WAN policies bindings. So this is where you you kind of map a policy to a site. Okay, so if you want to modify this, we currently have only one policy. You can select your policy for NAT, for QoS, path policy over here, and then apply it, and then it will immediately take into effect. Okay, so this is done, and then okay, so we have reached towards the end of the session. As I mentioned to you, this is just an overview of what we can do with these policies. It's an introduction. It's not deep dive into these because they are very big topics. Um, in future, we plan to do more sessions by other presenters, for these for the to go deep dive into this. Yeah.
Cool. All right, we did have a couple of questions come in. Looks like one of them just got answered. Naresh was asking, in the users section, can we add users?
So the users are picked up
I'm
from
sorry, can we
the
use AD users? I meant to say. I think yes. I'm sorry.
yeah. So the user is actually pre-populated from your cloud identity engine. So the moment you do the integration with CIE, the users get auto-populated. We cannot manually add users on it, and then we can apply user-based path policy, which is a new feature we have to for running a specific version of branch Ion to forward the traffic specific to these users. If you want to answer the question, can we add? We cannot add manually, but it can be added through CIE, Cloud Identity Engine. It gets pre-populated. It learns from the Cloud Identity Engine. So if the user is defined with your CIE or SAML, then it's available for you. The groups and users are available for you to configure.
Okay, I hope that answered your question, Naresh. If not, one of the nice things is this is just day 1 of 2 for the event. So we will be coming back tomorrow. Faisal, did you have anything more you wanted to say for today, or was that it?
Yeah, so today is just, as I mentioned, throughout the session is a foundational course, foundational session to understand the various building blocks of Prisma SD-WAN. We did see how these blocks interact with each other, and then we build a site based on these components. Tomorrow, what we're going to see is how to monitor, how to troubleshoot your Prisma SD-WAN, how to see, how to use this, how to use the portal Stata Cloud Manager to monitor what's going on within your network, and how to use the CLI to do this low-level troubleshooting, and to drive it. So today's session is to operate it. Tomorrow is to use the troubleshooting tools to fix your problems.
Fantastic. Yeah. So yes, for those asking about recordings at the same time, yes, it's be the same time tomorrow. The event is being recorded. It will be posted up in Live Communities, YouTube, and also on this event page in a couple of days after tomorrow's event is done. Just give us a little time. We'll actually literally give me a little time to get to it. I will be the one doing the actual video editing, so we will have it up for you shortly, I promise. Edward Pera did ask one last question of which software version for the Ions is the most stable to deploy?
Yeah, we have a community post where we have mentioned, based on your requirement, which would be the best version to go for. So if you are already a Prisma SD-WAN user, if you've been running for a long time, and you don't need the new features, you don't need the user base path policy, you don't need the OSPF, you have a recommended version for that, and then same applies. If you need this specific feature, you can choose this particular version of software. So there's a community page on it. I think Darshan or someone can reply on the chat.
Okay.
It's more tailored to what you need than to give you a one standard version, so that fits everything.
Gotcha. Okay. Are there any kind of testing labs available for this kind of thing, or no? Faisal, that was for you.
Yeah. Yeah. So for the testing lab available to public, it would be best to reach out to your accounts team to explore whether something can be done for you. But if you ask me, there's a course called Prisma SD-WAN EDU 238, which is a great course to get some hands-on with Prisma SD-WAN platform.
Oh, because I have the lab access in conjunction with the training materials.
Yeah.
Oh, fantastic. Cool.
So the thing is, what's very important part of this Prisma SD-WAN is to use it. If you don't use it, you lose it. So you need to apply what you learn. Since it's a very new way of doing things, you need to practice. You need to be a practitioner to keep on working on these different components to understand how it works. So when you learn it, you need to apply it. You need to find a mechanism by which you can do it.
Yeah, experience is key. It's not just book learning, you're saying. Yeah. What was that course that you just mentioned? Was that EDU 318, 380, you say?
EDU 238.
Okay, EDU 238, Tushar. That's the answer to your question there. So yeah. With that, then I will go ahead and let you go, Faisal. Thank you very much. I will go ahead and I got a few more minutes here, but I'll let you go ahead and go. So thank you very much for today, and we will see you again tomorrow.